Hello everyone. In this video, I'm going to talk about some technical terms in quantum model of atoms: shell, subshell, orbital, and I'm going to define and find relationship between each of them in this video. First, I'm going to talk about the structure of atoms. I'm sure you remember that each atom consists of a number of protons, neutrons, and electrons. And we can use this diagram to represent atoms. Protons and neutrons can be placed in the center. We call it nucleus, and electrons can be placed on the surface of the atoms. So I'm going to call this place of the electron shell. So shell is the place of the electrons. This is the first definition for place of the electrons in the atom is shell. If I'm gonna work on another atom, I may draw like this one. I may draw a number of shells. So one possible question: how many shells should be drawn if we have, for example, oxygen? How many shells should be reported if we have calcium atom? So to answer this question, I'm gonna work on some assumptions and conventions. At the end of this video, you are going to learn how many shells for each specific atom should be reported. When we have shells, I'm gonna call shells by shell number. Shell number. So this shell number, because this is a number, let me denote by n. So n is going to represent shell numbers. So if we have n1, it means we are going to talk about shell number 1. If we have n is equal to this number 2, it means we talk about the second shell, third shell, and so on. As you see here in this diagram, I drew higher shells closer to each other. So this is a real fact in this quantum model. Higher shell numbers, they are going to be closer to each one. So I'm going to talk about it a bit later in this video as well. So just wanted to make sure you understand. If we have this diagram in this video or other resources, you will see higher shell numbers. We are going to denote them by like this pattern, closer to each other. I'm going to work on some technical terms related to shells. In quantum physics, we can solve some equations to find energy of each shell. So we may call shells or energy level. So we may call each shell as one level. First shell, we call that energy level number 1. Second shell, this is the second energy level. So we are going to specify this diagram based on energy. So we can calculate amount of energy for each shell, electrons on each shell. So based on this new term, shell numbers can be called by one specific term. We call that principal quantum number. What does that mean, principal quantum number? In quantum model, we have 4 quantum numbers, and n, this is the first quantum number. First quantum number. So I wanted to give you this definition when you are going to study the different resources or working on different textbook. Energy level is another terminology we may use for shells. And if we are going to work on shells, we need to know the shell numbers. But shell numbers can be reported by principal quantum model or first quantum model. It's up to you which one is easier for you to learn or memorize or apply that one for your study and your calculation. Right now, I'm gonna work on n as a number and solve it based on some information you may extract from that. N is a shell number. So we are going to know how many electrons can be placed in each shell. How many electrons can be placed in each shell? If we have shell number 1, how many electrons we can put in shell number 1? And like this one. The equation we need to work on is the number of electrons in each shell is coming from this equation, 2n squared. 2n squared. What does that mean? Assume that n is 1. Assume that n is 1. We are going to talk about the first shell. If you put n as 1, you can easily solve that one. 2 times 1 squared. So you get 2. It means shell number 1 can hold up to 2 electrons. We can place 2 electrons in first shell. How about if we have shell number 2? Shell number 2, if we are going to plug in here in this equation, 2 times 2 squared. So the answer is 8. So shell number 2, we can put up to 8 electrons for shell number 2. As you see here, you can apply n as a shell number to find number of electrons for each shell. So next question is, how many electrons for shell number 3? So if I ask you in your exam, how many electrons in shell number 3? So you just need to plug in this equation 3, so you may find 18. So you may say 18 electrons. So I'm going to work on, for example, shell number 4. Shell number 4, and you are going to find 4 times 4 square, 32. 32 electrons. So just wanted to give you, if we have a variety of shell numbers, so you can easily find the number of electrons for each shell. So this is the first information we need to know regarding shell. This slide, it gives you all required information you need to know for this technical term, shell. Right now, I'm going to work on subshells. So we know for shells, we need to memorize 2n squared, and it gives us the number of electrons in each shell. Let me write like this, in each shell. I'm gonna draw like this one, shell number 1, shell number 2, shell number 3, shell number 4, and we have 2 electrons here, 8 electrons, and I'm sure you can easily say 18 and 32 electrons here. Right now, I'm going to work on another classification of place of the electrons, another classification of the atomic structure. I'm going to talk about subshells. Subshells. Please understand, we are going to work on a new place, or subshell is going to be another region of the atoms you may find the electrons. When we say subshells, to find relationship between subshells and shells, I'm going to give it you like this relationship formula. It's not very helpful for the higher shell numbers, but it would be helpful if you are going to memorize that. Shell number, it would be same as the number of subshells. What does that mean? Shell number it's going to represent the number of subshells. For example, shell number 1, it has shell number 1 has only one subshell. Shell number 2 has only two subshells. Shell number 3, I'm sure you are going to say 3 subshells. And shell number 4, we are going to have 4 subshells. So in chemistry, we have only 4 subshells. We have only 4 subshells. And this relationship, it gives you to memorize the number of shells, subshells in the chemistry. Shell number 1, it means we have one subshell. Shell number 2, two subshells, and so on. I'm going to call each subshell by one specific term, This specific term should be memorized. So always first subshell, we call that S, and we report it by lowercase s. So first subshell S. I'm going to work on shell number 2. Shell number 2 has two subshells. Please remember, I said always first subshell is S. And second subshell, I'm going to call that by P. So always first subshell S and second subshell is P. I'm going to work on shell number 3. Shell number 3, it has 3 subshells. First subshell always is S, the second one P, and third one is called D. As you see here, we do not have any relationship between subshells letter. S stands on sharp, P principal, and D diagonal. I'm going to work on the last one. Shell number 4, we are going to have 4 subshells. The first one is S, second one is P, third one is D, and last one is F. So in chemistry, I told you we have only 4 subshells. So if we have shell number 5, we still have 4 subshells. So this relationship works only to help you. We have like this information. After shell number 4, we always report only 4 subshells for each shell. Shell number 5 has 4 subshells. If we have shell number 6, we still have 4 subshells, and these subshells are S, P, D, and F. Right now, one possible question: how many electrons can be placed in each subshell? How many electrons are placed in each subshell? To answer this one, I may ask you to help me to derive this equation, to derive this number. And after that, I'm going to give it you how to memorize it. I'm going to write it here. This is the shell number. Let me write it here. Shell number. This is the number of electrons in each one. Right now, I'm going to work on subshell letters. Shell number 1 has S. Let me write by another color to make sure you can get that one better visually. Shell number 2 has 2 subshell S and P. Shell number 3 S, P, D, and shell number 4 S, P, D, and F. Right now, I'm going to work on number of electrons in subshells. Here we have number of electrons in each shell. Shell number 1 can hold up to 2 electrons, and we have only one subshell. It means this subshell can hold up to 2 electrons. So shell number 1 can hold up to 2 electrons, and we have one subshell. It means S subshell can keep only 2 electrons. So I'm gonna write it here. S can hold up to 2 electrons. Let me write like this one. S2. I'm gonna write this number on the top to say S subshell has 2 electrons. How about the second shell? The second shell can have 8 electrons. For S, always 2. How about P? I'm sure you can say for P, we are going to have 6 electrons. So 6 and 2 totally make 8 electrons for shell number 2. So when we have S, always write up to 2 electrons. For P, we are going to have up to 6 electrons. So 2 for 6, 2 for S, and 6 for P. How about shell number 3? Shell number 3 can hold up to 18 electrons. It can keep 18 electrons in this shell. For S, we have only 2 electrons. For P, up to 6 electrons. And totally, we have 8 electrons here. The remaining electrons can be placed in the D subshell. It means 10. So I'm going to write the information for D here, 10 electrons. So always D subshell can hold up to 10 electrons. If you are going to work on this pattern, I'm sure you can easily find the number of electrons for F. 2 electrons for P, 6 electrons for P, 2 electrons for S, 6 electrons for P, 10 electrons for D, and we are going to have 18 electrons here. But in shell number 4, we can have up to 32 electrons. So the remaining electrons make 14 electrons for F. So I'm going to write F can hold up to 14 electrons. So I'm going to write 2, 6, 10, and 14 electrons. The reason I wanted to write it here, I wanted to show you we have always 4 electrons added to each subshell. So 2 plus 4, it means 6 electrons, 6 and 4, 10 electrons. So this is the interval between the subshells. So you just need to memorize this information. You just need to memorize this information. S, 2 electrons, P, 6 electrons, and D and F, 10 and 14 respectively for this pattern. How to memorize these numbers? 2 electrons for S subshell, 6 for P, and D, 10, F, 14. Right now, I'm going to ask you to look at this slide, and I'm going to show you what is the relationship between the periodic table of elements as well as subshells. So I'm going to write this information here to remind you. S, 2, P, 6, D, 10, F, 14. So I showed you if you want to derive by yourself, you just need to add number 4 to each one to find the number of SPDF. So like PDF, so you just need to say SPDF. So easy to memorize. If we are going to find the relationship between these subshells and the periodic table, I'm going to work on this pattern. I'm going to work on this pattern. So first, let me work on this side of the periodic table. In the periodic table, on the left side, we have 2 columns. We have 2 columns. Let me highlight that one, 2 columns. These two columns, we call the S block. S block. So two columns on the left side of the periodic table, two tall or longest column, so we call them S block. So whenever you are going to memorize S, you may say 2. If we are going to work on right side of the periodic table to find the number of groups, you may find 6, 1, 2, 3, 4, 5, 6 groups on the right side of the periodic table. So on the right side of the periodic table, we have 6 groups. So on the subshells, 6 belongs to P. So we call this side of the periodic table P block. P block, it means we have 6. So you can easily memorize 6. Then we have D subshell with 10 electrons. So I'm gonna work on this side here. In the middle of the periodic table, if you count number of groups here, short columns, transition metal groups, you may find 10. So let me count them to make sure we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So fortunately, we find 10 here. So I'm gonna call that one D block. So D block. And when we are going to work on electron configuration of the elements, you may find this information are helpful to know the place of the electrons as well. But here we are going to focus on only the methodology, terminology in this method. So we call it D block. And for F14, the only region in this periodic table, it remains in this portion. So if you count the number of groups here, you may find 14. So I may ask you to do by yourself. So 14 groups in the periodic table on the inner transition metals on the bottom of the periodic table. So we call this part F block. I just wanted to show you when we use the periodic table of elements, we have this design for the periodic table. So it helps us to also remember S, P, D, and F. So you can easily say that for S, we have 2 groups. For P, we have 6. So I'm going to write it here by this color. Let me write it here. 2 for S, 6 for P, 10 for D, and 14 for F. So this is a classification for shells and subshells. And finally, we have orbitals. We have orbitals. So I'm going to define orbitals of atoms by one most commonly used definition we have for this region of atoms. So we say an orbital is a region where we have a very high probability of finding the electron when it has a particular amount of energy. What does that mean? We talk about highest probability. If we work on subshells, we are going to work on another region in the subshells. We call that orbitals. So orbital, it means we are going to focus on another place in the atom when we classify the subshells for finding electrons. Let me give you like this example. If we have a building, each floor in the building represents by shell. If we have a building with 5 floors, it means we have 5 shells in the building. Then if we have units per floor, units per flow, we call that subshell. So shell number 1 has 1 unit, it means S. Shell number 2, floor number 2, it has 2 subshells, 2 units, and so on. And if we are going to work on the rooms in each units, so we call that orbital. So it means we are going to find the place of the electrons step by step. We say that in the building, first we need to go for the first shell, then we should look at the S unit. In the S unit, we need to find a room. So in the unit. So we are going to have this number of orbitals in each subshell. Number of orbitals in each subshell. But before working on this, I'm gonna give you this magic equation or magic relationship. Each orbital can hold up to 2 electrons. Each orbital can keep up to 2 electrons. 2 electrons in each orbital. The reason, because electrons have negative charge particles, we cannot keep them close to each other. Up to 2 electrons, it can be possible. So we have one rule for this one. You may watch other videos to work on this one. 2 electrons, they can have minimum repulsion for the keeping electrons in the orbital. So let me work on this part. S, P, D, F. 2 electrons, 6, 10, 14 electrons. Each orbital can hold up to 2 electrons. So I'm gonna say S has only one orbital. S has only one orbital. And we call that S orbital. We call that S orbital. P can hold up to 6 electrons. And we have 2 electrons for each orbital. It means P has 6 orbitals. 6 orbitals. D can have up to 10 electrons. It means 5 orbitals for D. And F, it can hold up to 14 electrons. It means 7 orbitals. So orbital is the place of atom you may find electrons by highest probability. The reason we need to know this information because we prefer to find the place of the electrons in the atoms. And you know that electrons are orbits. Electrons are moved and they orbit. That is why we cannot find the exact place because they move. So we may talk about probability to find the electrons. So this type of information just reviewed by quantum model of atoms. And in other videos, we are going to learn how to work with the orbitals and working on electron configuration of atoms. Thank you for watching this video.